In today's lesson, you will see students engaging in a math flip. This is an effective and easy-to-use resource created by Berkeley Everett. The idea that 3 times 5 has the same value as 5 times 3. Knowing this helps build fluency and reduces the amount of multiplication facts a student must memorize. A math flip is a 10 to 15 minute number sense routine in which students are presented with a flashcard that has a problem on the front and a related problem on the back. You'll notice this is different from traditional flashcards, in which you have a problem on the front and an answer on the back. This routine encourages students to see and use relationships between 2 different representations for multiplication. By encouraging students to discuss similarities and differences between the models, they develop a deeper conceptual understanding of multiplication and the commutative property, which will support students in developing mathematical fluency.
Look at this image and I want you to give me a thumbs up when you can tell me how many dots you see. All right, how many dots do you see?
12.
All right, 12 dots. All right, how do you know that there are 12 dots there on the image?
Because I added both of those right there, and that made 4, and I just added all of them together.
So you added these 2 to get 4. Then what did you add next?
The ones underneath that one.
These 2? So you added 2 and 2 again, and you got what?
And the 2 4s equals 8.
Okay, then what'd you do?
And I added another 4
And where did that other 4 come from?
right there.
Those 2.
Okay, so you guys used addition to solve this image. Did anybody use a different way?
3 plus 3 is 6.
Okay, 3 plus 3. Where's your 3?
The 3 are the circles.
So you saw these 3 circles, okay, and then you saw the other 3, and so that's where you got your 6?
Yeah.
Okay, and where did the 2 come from?
The ones and the circles.
So the number inside of each circle.
All right, let's look at our next image. How many dots do you see for image B?
12.
All right, so you see 12 dots. Can you justify how you see 12 dots?
I counted by 3s.
Oh, so where do you see your 3s?
Going up and down.
So right here,
Yeah.
and then these. So what did it sound like when you were counting by 3s?
3, 6, 9, 12.
Okay, does everybody see where her 3s came from?
Did anybody see it a different way?
2 times 6.
2 times 6. Okay, justify how you saw 2 times 6.
It's 2 groups, and it's 6 in each group.
All right, very good. 2 groups with 6 in each group. So I want you to look at image A and look at image B. All right, and let's look at how they might be alike and how they are different. Can you tell me how they're alike?
They got the same total.
They have the same total number of dots. What do we call our answer to a multiplication problem?
A product.
A product, very good. So our product was 12. Okay, what about a way that they're different? How are these images different?
Because on A, they have 6 groups, and on B, they have 2 groups.
In image A, we saw 6 groups with 2 dots inside each group.
So 6 groups of 2.
6 groups of 2. And for image B, we saw 2 groups with how many inside each group?
6.
Very good.
This routine encourages students to see and use relationships between 2 different representations for multiplication. By encouraging students to discuss similarities and differences between models, they develop a deeper conceptual understanding of multiplication and the commutative property, which will support students in developing mathematical fluency.
Okay, so now let's take a look at this slide. I want you to give me a thumbs up when you can tell me how many dots you see for slide A. All right. Can you justify how you saw 14 dots?
I counted by 2s.
Okay, so counted by 2.
2, 4, 6, 8, 10, 12, and 14.
Very good. Okay, so you skip counted by 2s to get the total number of dots. All right, good. Did anybody solve it another way?
So I saw 7 groups in all.
Okay.
And when I looked inside of the groups, then I saw 2 dots in each group.
7 groups. 2 in each group. Okay. What kind of an equation did you do for that?
7 times 2 equals 14.
All right, so let's move to slide B. Okay, same thing. I'm going to give you some think time, and then I want you to give me a thumbs up when you can tell me how many dots you see on the screen. How many dots do you see for slide B?
14.
All right. Can you justify how you saw 14 dots?
2 times 7 equals 14.
All right, and where did you see 2?
My 2 groups.
2 groups. And where did you see 7?
The 7 dots inside my 2 groups.
7 dots inside. Okay, how did you get 7 so quickly?
Because I recognized my 5, and then I recognized my 2, so I just add them together.
Very good. All right, so how are slide A and slide B alike, and how are they different?
They're alike because they both got 14.
Very good. They're both alike because they had a total of 14 dots. How are they different?
One of them have 2 groups, and one of them has 7.
So slide B had 2 groups, and slide A had 7 groups. What about the dots? What do you notice about the dots inside the groups?
On A, there's only 2 dots,
Okay, so there's,
and in B, there are 7.
in slide A, there are 7 groups of 2 dots, and in slide B, there are 2 groups of 7 dots. Okay, so how does slide A help you with slide B?
They both have the same product.
Very good.
A good math routine has multiple opportunities for teachers to use the mathematics teaching practices and for students to develop their own mathematical reasoning skills using the student mathematics practices. As we watch a math flip taking place, we can clearly see that the teacher poses purposefully crafted questions to facilitate meaningful discussion and support students' productive struggle. Through the use of visual models, the teacher promotes multiplicative reasoning and problem solving as students are justifying their answers and explaining their strategies.
All right, guys, we're gonna look at one last image, okay? So how many dots do you see?
16.
How did you get 16 so fast?
8 plus 8 is 16.
Okay, so tell me where you see 8.
A at the top end, and this is A at the bottom.
Okay, so you saw one row of 8, and then another row of 8. Okay, so 8 plus 8 does give you 16. All right, did anyone else solve it another way?
8 times 2,
All right, and where did you see 8?
across,
Okay, so 8 going across. And where did the 2 come from?
going down.
What was it called before we put these circles around it? Does anybody know what that was called when we just had our dots set up like that?
Array.
It was called an array. So we saw an array and then we thought about it in our mind and we made it into some equal groups too. The teacher also supports students to make connections to the mathematics using numbers, symbols, and equations. This provides an opportunity for students to build procedural fluency from a conceptual understanding by noticing relationships between the representations.
All right, so I'm gonna show you another image. I want you to give me a thumbs up when you can tell me how many dots you see on the screen, but I also want you to think about how did this image help you with this one you're about to see. Okay, so go ahead and be thinking about that in your brain. How many dots do you see for image B?
16.
Can you justify how you guys saw 16 dots there?
That one, but it's just that you turn that one that way.
Oh, so we turned this one up like this. Okay, so what do you think an equation would be over here?
2 times 8.
All right, Wyatt, where do you see 2?
Going across.
Okay, so 2 going that way. All right, and what about the 8? Where do we see 8?
Going up and down.
Going up and down.
Using math flips, teachers can provide opportunities for students to engage in several of the student mathematical practices. The routine is designed to facilitate discussion that allows students to construct viable arguments and critique the reasoning of others. Students also make sense of problems and persevere in solving them. Through the use of a visual model, all students have an entry point to make sense of the mathematics at their current level of understanding. Because all students have a way to enter the task, they feel more confident in their mathematical abilities and are more likely to take ownership of their own learning.
All right, guys, so I want you to think about how side A helped you solve side B. Then I want you to think about how these two sides are alike and different. Okay, so I'm going to give you just a few seconds to think about that. All right, now I want you to turn and talk to your neighbor. Tell your neighbor what you noticed about side A and side B.
So
Okay, all right, who would like to share what you or your partner talked about?
on A, it's 2 going down and 8 going side. On B, 2 is going side and 8 is going down.
Okay. They're different because A is going across and B is going up and down.
Very good. Okay, so they just switched positions, right? Okay. All right, so you guys did an awesome job of noticing the relationships using multiplication strategies and the commutative property efficiently. I love that you guys used relationships to share your ideas to make math easier.
Every student has a voice in justifying their strategies. This builds flexibility, efficiency, and accuracy in mathematical thinking. If you're interested in adding math flips or other number sense routines to your math classroom, reach out to your regional AmSty specialist through amsty.org.